Okay, in this video, we're going to do a quick recap of factoring what we call simple trinomials. This is not meant to be a substitute for the lesson we did in class or the note that we took together, but it's just going to be a quick, I'm going to go through 5 examples, just go over some strategies on how to solve these. First of all, why do we call them simple trinomials? Well, first of all, they're trinomials because they have 3 terms. So I've got a squared term with an x, and then a constant. Why do we call them simple? So they're in this form. You may recognize this from the last unit. They're in the standard form, ax squared plus bx plus c. Everything we do in this video, the a value is going to be 1, right? So the coefficient, we don't see it, it's just a 1. So that's what we call a simple trinomial, ax squared plus bx plus c when a equals 1. And as we discussed in class, I'm always looking for 2 numbers that multiply to my c value and add to b. So in this case, I'm looking for 2 integers that multiply to 12 and add 8. There's always going to be only one pair of numbers that satisfies both of those criteria. You can kind of brainstorm, what are the numbers that multiply to 12? You've got 1 and 12, you have 2 and 6, you have 3 and 4. Well, positive 2 and positive 6 multiply to 12. So our answer, well, first of all, factoring is the opposite of expanding. So when I'm expanding or multiplying 2 binomials, I know if I've got x and x, that would multiply to x squared. And then I'm just going to plug in my 2 numbers, positive 2 and positive 6, and I'm done. Okay. So when I'm factoring a simple trinomial, I'm just looking for 2 numbers that multiply to c and add to b. And because factoring is the opposite of expanding, I can just check by multiplying out or by using FOIL. So factoring means we write as a product. So here it's a product of 2 binomials. You can also think of that as putting numbers back into brackets. Then I could use the distributive property, where we've been using the acronym FOIL. Instead of x squared, x times x. Then I'd have outside, x times 6 is 6x. Inside, x times 2 is 2x. And then last, 2 times 6 is positive 12. And then I collect. So this should be pretty familiar to everyone by this point. And I'm back to where I started. You can always check any factoring question by expanding and vice versa. We're kind of learning how to go forwards and backwards. I'm just going to do a couple more examples to talk about some of the strategies. So again, I would figure out what are our goals. We're trying to find 2 numbers that multiply to 90 and add to 21. I recommend a systematic approach. So I recommend writing down every factor pair that multiplies to 90. So of course, we always know 1 and 90. Then I would write down every pair that you can think of that multiplies to 90. If you do it in order, you know you're not going to miss one. So 90 is even, so we can divide it by 2. 90 can divide by 3. It can't divide by 4. So if you're doing this with your calculator, you're going to get 22.5. If you divide by 4, we can't have decimals. I can divide 90 by 5, any number that ends in 0 or 5. I can divide it by 6. Can't do 7, can't do 8, and then I can do 9 as well. So as we practice more, the more efficient or the quicker you can generate these pairs with a calculator, with a times table in your head, the easier these problems are going to become. These are all the pairs of numbers that multiply to 90. I don't have to keep going. The next number I would want to try is 10, but I've already got 10 as the other part of the pair. So now I'm just going backwards. So you've only got to go up to the square root. Once you start noticing that you're trying numbers that are bigger than what you already have written down, you can stop. And then only one of these pairs is going to add up to 21. So they all multiply to 90, but only 6 and 15 multiply to 21. So this will be factored as x plus 6, x plus 15. So I think a systematic approach really helps, especially when your c value is relatively large. Again, we've already done most of the problem. I know it's going to look like the product of 2 binomials with just x and x as my first term in each. This time I'm multiplying to negative 28 and adding to a positive 3. I would start the same way. What are the pairs of numbers that multiply to 28? Well, it's 1 and 28, 2 and 14, 4 and 7. Well, this time it multiplies to a negative. That means the signs have to be different, right? We have to have 1 negative and 1 positive to make a negative. So in each pair, one of the numbers has to be negative, but it adds to a positive. So another way of saying that is it adds to a positive. The bigger number is going to be positive because it's got to outweigh that negative. So again, these all multiply to negative 28, but only negative 4 and 7 add to positive 3. And then again, if you wanted to, you could check by expanding. So again, my recommendation is to use a systematic approach to write out your pairs. Think carefully about signs. What does it mean to multiply to a negative? What does it mean to add to a positive? We'll just do a couple more together in this video so you get the hang of it. We're always multiplying to C. We're adding to B. Remember, the sign in front of the term goes with the term, so B is a negative 11 here. Well, what multiplies to 24? 1 and 24, 2 and 12, 3 and 8, 4 and 6. So again, I'm doing them in order so I know I don't miss any. 24 is not divisible by 5. It doesn't end in a 5 or a 0. Okay, this time it multiplies to a positive. So that means you either need two positive numbers or two negative numbers multiplying together. But if it adds to a negative, well, it can't be two positives, so it must be two negatives. I can add all my negative signs, and now I'm just looking to see which of these four add up to negative 11. So negative 3 subtract 8 is negative 11. You're welcome to, of course, double check things with a calculator. And you can tell that when I expand, when I do my last step, it'll be negative 3 times negative 8, and that's where the positive 24 comes from. This one looks a little bit different. I told you simple trinomials, the a value is always 1. A value is not 1 here, so what's going on? Well, we can always look and try to common factor first. Common factor means what do these three terms share? What are they divisible by? They're all divisible by 3. So what I can do is divide each of these three terms by 3 and put whatever I'm left with in the brackets. Divide by 3, I get negative x. Divide negative 18 by 3, I get negative 6. So once I've common factored, now I do have a simple trinomial. So now I can leave my coefficient out front, and I can factor by looking for two numbers that multiply to negative 6 and add to, well, what's in front of my b value? It must be just a number. It's 1. So what multiplies to 6? It's either going to be 1 and 6 or 2 and 3. It multiplies to a negative, so 1 will be negative. This time it adds to a negative. So the negative number must be larger. It's got to kind of outweigh the positive. So I've got 2 minus 3 is negative 1, so that's going to work. So I've got x plus 2 and x minus 3. So even if sometimes it doesn't look like a simple trinomial, you can find a common factor, it might turn into a simple trinomial, which we now know how to factor, which means to express as a product, in this case, of two binomials. So again, this isn't meant to be kind of a comprehensive lesson, but if you're stuck on the homework, I think this is just some strategies, things that I like to write in the margins to know that I'm on the right track and to know that I'm following some sort of system. Okay, let me know if you have any questions with factoring trinomials. If you do, send me an email, and otherwise, thanks for watching the video.